All right, given the truss shown here, we want to figure out the force in each member of the truss. Now, the first step in doing truss problems, you don't have to do this one, but in general, it's a good idea, is find your reactions on the entire structure, the entire truss. Okay, so I'm going to have C there, I'll have BY here, and I'll have BX right there. Okay, and again, now I'm taking this for the entire structure. So we'll sum the forces in the x on the whole thing. We have bx, and then we have minus 375, and those are all of the forces there. So that is equal to 0. Therefore, bx equals 375. Sum the forces in the y direction. I get by. I have c, and I have negative 500, set that equal to 0. Then I'm going to sum the moments. I'll do it about B since I've got two forces there, so I'll have 6 times C minus 14.4 times 500 plus 8 times 375, excuse me. So the moments of all of those external loads, except for the ones at B, because they create 0 moment about point B. So from that, I can find that joint C is 700. The reaction at C is 700. And then plugging that up here, I can find the BY is negative 200. And all that negative tells me is I've drawn that in the wrong direction. So again, those are those reaction forces. That's the pin at B and the roller at C. Find those external reactions going on there. Now, because I want to find each member, I'm going to go ahead and do a joint analysis. Okay, and I need to choose a joint that has no more than two unknowns acting on it, which for what we have here, I can either start at B or I can start at D. And I'm going to start at D. Also note, I could have started at joint D here without finding those reactions, okay? Because I have the known 500 pounds and then the two unknown members, CD and AD there. So I didn't really need to find what's going on at B and C before doing it, but you're never wrong to do that, and it's a good idea to always have those values. So I'm going to go ahead and start with joint D. I'm going to include the external loads that I've got going on there. So that's the 500. Now, the other forces, this is again, I'm drawing the free body diagram of the joint. So what I do is I assume both members, all members are in tension until I prove otherwise. And if they're in tension, right, they're going to be pulling on the joint. Again, the Newton's third law says the joint pulls on the member to make it in tension. So equal and opposite reaction, the member pulls on the joint. So I'm going to have a force CD to the left and a force AD up and to the left. Again, I'm going to assume they're both in tension. And I can do an inverse tangent of 8 over 8.4, and I get an angle of 43.6. You can go ahead and double check me on that. Okay, but that's the angle between those forces. So there's my free body diagram. Again, remember we're doing the free body diagram of the joint. We assume any unknown forces in tension. If I'm wrong, I get a negative answer and it's actually in compression. But I always assume tension, and that tension is going to be pulling on the joint, just like the joint is pulling on those members to put them into tension. Okay, so those arrows are always going to be going out from the joint. So from this, I can go ahead and sum my forces in the x and y direction, set them equal to 0. So I'm going to have negative FCD minus FAD, and this will be cosine of the 43.4 equals 0. Do the same thing in the y direction. I'm going to have negative 500 plus FAD, but now this time it's going to be sine of 43.6. That equals 0. Again, because CD is horizontal, 500 is negative or vertical, they all just show up in one of the members. Now, I'm going to go ahead and solve these two equations. Again, that's why I have to choose a joint with only two unknowns, because I can only solve two unknowns with these two equations that I'll get at a joint. I don't have any moment equations. All the forces are going through the same point. So in solving this, I find that FAD equals 725 and FCD equals negative 525. And I go ahead and I do the solving first, and then I analyze what I've got there. Okay, because if the values are positive, then my assumption that their intention is correct. If they're negative, then that assumption's incorrect and they're actually in compression. So FAD is going to be 725 pounds in tension, whereas FCD will be 525 pounds in compression. And it's best to draw them or write them that way. Don't just leave them positive and negative. Actually say tension or compression, because that's what we're actually interested in. Then I'm going to come back up here so I can keep track of what's going on. And I'm going to say, okay, this one's, I'm sorry, 725 in tension. This one's 525 in compression. Okay, so at this point, okay, I need to move on to the next joint. And again, I go to a joint that only has no more than two unknowns at it, because I can't solve any more than two equations at a time with these joints because I only have force equations. Really, I can go anywhere at this point. I'm going to choose joint C because everything is either horizontal or vertical, which should make my life pretty easy. Again, I've got the reaction at C that I've got to remember. I've already found that to be 700, so just keep that in mind as we go through this. So I'm going to move to joint C, okay? And again, remember, I've got my reaction. I know this is 700. I've already calculated that. The other thing that I know is that CD is in compression at 525, okay? So if it's in compression, it's pushing on that joint, just like the joints are pushing on it to put it into compression, okay? So that 525 is into the joint like that. Then I have FBC and FAC. Again, I'm going to assume their intention. If I'm wrong, I get a negative answer, okay? So if I assume their intention, they're going to be out from the joint pulling on it, okay? Once I have that, I can go ahead and sum my forces in the X direction, and I get negative FBC minus 525 equals 0. And in the Y direction, I get 700 plus FAC. Now again, I chose this joint because everything was horizontal or vertical. I knew the math would be a little bit easier for this. So then from this, I get that FBC equals negative 525. And from this one, I get that FAC is going to be negative 700. Okay, again, those negative signs mean my assumption that they were in tension are incorrect. So this is actually going to be 525 pounds in compression, as this one will be 700 pounds in compression, like so. Again, I'm going to go back up and jot these in so I can keep track of what's going on. So this is going to be 525 in compression, and this one here will be 700 pounds in compression. Again, this helps me keep track of what I know and what I don't and where I need to move, because now what I need to do is I need to go to another joint. I can either go to A or B. I need to find AB. It's the last thing I know, so I can go to either member. I'm going to go over to B because if I go to A, I've got two members at an angle there. Again, less calculus, the better for me anyway. So I'm going to go to joint B here. And I'll start with what I know. And again, I have those reactions, right? So I know that Bx is 375 and By, now notice I have a negative value there. So that was drawn incorrectly originally. So I'll draw it correctly this time, downward of 200. Remember when I originally did it, I assumed it was upward, got a negative answer. So that was incorrect. The other thing I've got here is I have 525 in compression. So again, that's going to be in towards the joint, pushing on it like that. And then I've got AB, which again, I don't know. Okay, I'll assume it's in tension, so out from the joint like so. This is a 3, 4, 5 triangle. Okay, so I'll deal with that. Now, I just have one unknown, so I really just need one equation. I'm going to do the Y equation because I've only got one other force vertically, so that should get it done for me. So if I sum the forces in the Y direction, I have negative 200 plus, and that will be 4/5 FAB equals 0. From this, I learned that FAB is 250. Okay. Positive means I got it correct. I assumed tension. It is in tension. So that's going to be 120, or I'm sorry, 250 pounds in tension. And just to clear things up, complete things out, I'm going to go ahead and jot that up there too. So now I know I have all of my members accounted for. I know the force, tension, compression through each member. So again, with these joints, start with your reaction forces, then go joint by joint, choosing a joint with no more than 2 unknowns at a time as you move through, and then use your some of the forces in the X and Y to solve for those up to 2 unknowns, and move all the way through until you complete it.